Next up we have tuples. So we covered this before as well. Tuples are an interesting data type. They're similar to lists, but they have two important differences. One is that they are immutable, which means they can't be changed in place or appended to. If you want to change a tuple, you have to store it as something else. And they can be composed of mixed type objects. So they can have multiple types in them, whereas typically with lists, we try to keep them to a single kind of object. Although lists, as we saw earlier, can support multiple kinds of objects. So they work very similarly to lists. So here we're going to store a tuple as 1, 2, 3, 4, and we see that it has a representation with parentheses instead of square brackets. And indexing works the same. It also has this length function, len, and concatenation also works. But if we want to, and we can do something like this. So we can store. In this case, we're not. We said tuples are immutable, and that's true. We're not actually changing the tuple. We're concatenating that tuple with a second tuple, and we're storing it as something else, which just so happens to have the same name as the tuple we had before. Right. So I can execute this cell again, and I'm going to keep adding to t. So when I say t equals t plus 5, 6, I'm saying this tuple concatenated with this tuple is now going to be renamed as, or it's going to be named as this thing, which previously, so we're now overriding what t was before. But if I uncomment this line and I try to store a value as like this first index here, t0, it's going to say, it's going to give me a type error, which means this type doesn't support, this tuple object does not support item assignment. So it won't let us do that. Tuples versus lists, here's a quick example. So we have a list here of some names. We could also have a list with names and a number in it, but instead of doing that, it's better to use a tuple. So for example, we want to have first, middle, last name, and age. So Billy Bob Joe is 42, and Robert Smith is 31. He doesn't have a middle name. So here we have these tuples with different data types, and then the list is the list of tuples. So just a way to kind of differentiate how we handle different data types. For most of what you're doing, lists are fine, but there's certain cases where it's nice to have a tuple. Okay, dictionaries. So dictionaries are really powerful. Everything we've seen with lists and tuples are cases where you have a list of objects that are sort of just in a particular order, or but there's no the only way that you can get a value is by the index, right? By its position in the list or in the tuple. So I know that the element I want is the 5th element in that list. So I'm going to use index 4, and I'm going to get that element that I want. But what if you don't know where in the list that object is? Another option for you is to use a dictionary where you have a key-value pair. So the value would be like the elements in the list, and the key would be like the index. But the nice thing about dictionaries is that the order doesn't matter. So you have, instead of having an index, you have a key, and that key points to the value. And so internally, even they're stored without respect to order. So here's a dictionary, and with dictionaries we use these curly braces, And when we first define them, one of the ways we can build a dictionary is by saying, I'm going to put this first, the key here, and then a colon, and then the value. And then another, and then a comma, and then another key, and then a colon, and then another value, and then a comma, and then another key, colon, and another value. So that's going to be dictionary that we call D. And then when we look at when we print the value of the dictionary just by typing it in our Jupyter notebook and hitting enter, we can see how it's represented. So it looks the same as how we typed it, except that the order is different. This is because Python saves memory and it saves speed by creating this sort of hash table that doesn't maintain the order. This makes it faster. If you need order, there are ways to do it, but typically it's not stored in any particular order. So you can't depend on them being stored in a particular order. But what it's really nice for is being able to look up a value very quickly using the key. So instead of typing, if this was a list, we'd type the name of the list and then the square bracket and then the index. Same thing with the tuple. We'd type the name of the tuple and then the square bracket and then the index. With the dictionary, it's just slightly different. Instead of the index here, we put the value of the key. Or I shouldn't use the word value. We put the name of the key, and that will spit out the value of that key value pair. So the same thing would be true of this quantity. So we could do D square bracket quantity, and tab completion works here too because the notebook knows that this is a dictionary and that has this key. So quantity here is 4, just like we entered it. But if we type dictionary D bracket quantity and then plus equals 1, we can add a value to it, and now if we print that dictionary, we see that the quantity has been changed to 5. If we want to initialize the dictionary, we can use curly braces. So this is going to erase what we had. So we can type that, and now if we type D again, we'll see that it's empty. So there's another way we can enter keys and values. So instead of doing it like we did up here in this type of notation, we can just pass the keys like this and then the values. And again, there's no obvious order to. We entered them in this order here, but then in the dictionary they're stored in a different order. That's just how it works. And again, we can pull out the value using the key. It's possible to do. You can put many different things in the value. So you can put, this is the value that's actually another dictionary. This is a value that's a list, and this is a value that's a floating point number. And these are all values. So if we wanted that name dictionary, we'd type the key for that key value pair, and it gives us the value, which is actually another dictionary. And so if we could do a nested dictionary, so we can get the last name. So for example, this is a person, this is his name, his job, and his age. So if we wanted the last name, we could do it the name and then last. Again, we can get if the job is a list, we can do a nested lookup and get say the last value in that list. And we can do things in place too. We can add another job to this list by using this append function, because remember that this value here, or this expression here, refers to the value of this thing, but when we append something to it, it goes back and actually modifies the original object. So here we'll see another example of how we deal with sorting. So here we have a list where we have A, B, C, D, E. This is not working the way I intended. So these are supposed to not be in order, but just by, I think, dumb luck, they're in order. But if we want to sort by keys, we can use this expression. So we're doing a for loop basically. So we're iterating over all the elements in the dictionary. And in this case, we're saying for a key in this sorted dictionary, print the key and the value. This example is failing right now because for some reason, the dictionary is coming out in order already, so it's not working. But there's another nice thing about dictionaries is oftentimes if you want to get the value of something, if you try to get the value of, that corresponding to a key, and the key doesn't exist in your dictionary, it'll give you an error. So here we have a dictionary that has 4 keys, A, B, C, and E. If we say E in D, it's true, but if we say F in D, it will say false. So if we tried to get the value corresponding to F, it would print an error. We'd get an error, and it would stop our code from working. So we can say, if we wanted to avoid doing this, we can say if not F in D. So if F is not in D, print missing. So we can use a variation of this expression to check if that key is in our dictionary before we check on it, before we try to evaluate it. One other really handy thing with dictionaries is if you have 2 lists, and remember lists are in order always. So lists have a particular order depending on how they're structured, how you entered them, and you have 2 lists of the same length and they correspond to each other. So let's say you have the keys are in one list here, and the values are in another list here. You can zip them together. And then create a dictionary from that. So there's 2 functions that go into this. There's this zip function, which creates a particular kind of object. So we're zipping the keys and values, and then from that we create a dictionary. So we use this dict function. So when we execute this, we then have the city, the job, the name, and the zip code. And even though they're not in the order that we entered them, they are paired up correctly, which is the important part. I'll go through this quickly. First, I'll stop the video here for a second.